Okay, today, or in this video, I'm going to be just basically cleaning up a lot of the work I've already done. I've got all these jumper wires on this breadboard, just looks like spaghetti right now, and I really need to clean that up before I go any further, because I'm going to be running wires up from this breadboard through to the second level. I'm going to be I'm probably going to put another breadboard in right here, and just to make a little tie-in point for the sensors and the LCD up top. But before I do that, before I expand up to the top level, I want to go ahead and clean all this stuff up now. So I'm going to be pulling these jumpers out and replacing them with little pre-cut correctly sized jumpers. So, but before I get started with that, I just want to show y'all what I'm doing. If you watch my test run, I was running four alkaline batteries for 6 volts. They're in this battery pack's in series, so it's 6 volts, which is twice what the little Tamiya twin motor gearbox motors are rated for, and they'll last about an hour like that. So what I'm doing is I'm cutting out one cell here with this little jumper wire, and then I'm going to use rechargeables, which are 1.2 volts here, here, and here. So I'm going to have motor voltage of 3.6 volts after I get done with that. Also, I was trying to run the Arduino off the battery pack too. I think it's just going to be easier just to throw a 9-volt battery in here and feed that to the voltage regulator on the Arduino, and then take the 5-volt output and put it on the power rail here, and then I'll also run that same 5-volt up to the top deck. So that's the only real design changes I'm going to make. I'll also be taking the output of the battery pack, going straight into the motor driver, because that's the only place we're going to need it, is on those VMOT pins on the TB6612. So if you're not really interested in watching me clean up wiring, then I suggest you go ahead and skip to the next part. Otherwise, you can go ahead and feel free to watch me finish this up and listen to me babble while I do it. And if I get my head in the way sometimes, I apologize, but my vision is pretty bad, and this stuff is pretty small. So let's see, it's just going from there to ground. I'll back it out. We don't need I won't back it out. It's already backed out. Be doing a whole lot of stripping wire, cut wire. Try and get it the right size. And I know if I don't do this now, I never will. So, because once I get this robot up and running, I'm just going to want to play with it instead of neatening everything up. I know how I am. Okay. Okay. And I'm going to go ahead and pull these motor connections out for now. I'll do them last. I didn't realize how many connections I already had in here. This is crazy. Let's see. Okay, we're going 14 to 24. That's about right. I'm just kind of guesstimate on the wire distances. It's not real critical. These are just going to lay so much flatter than those jumper wires. These are jumpers too, but when they're low like this, they're much less likely to get pulled out by accident. Okay, 23 going to ground. Okay, I think I'll just go straight across. And I'm not going to cry and die this. One idea I did have is I think it would be pretty cool. I've been wanting to play around with building a circuit, one of these circuit design tools, and then having one printed, having my own PCB printed. And I was thinking it might be cool to have to make my own controller, like robot controller, and integrate it with some microprocessor and one of these chips. I could do it like if I use the MSP430 chip and then this TB6612 chip. I could do it for less than $10. Okay, now we're going 12 to 25. Sometimes I'm going to have to stop talking whenever I'm kind of concentrating here. But I think that would be pretty cool to design my own little robot controller. With a motor driver built into it. That'd be fun. And simple. It'd be a nice simple design for my first board. Okay, yeah, these are going to be way neater. And the further I go here, 27 to 29. I actually have this. This is the feed for the 5-volt rail. So then I'm going to pull this. That's actually going to go here. Okay, so I'm going to make a real short jumper. Could switch these positions here and here. I'm going to make a real short jumper from 29 to positive. Positive rail. When I said short, I might have overdid it here. Let's see.
Okay, 29 to positive. Yeah, I might have overdid it here. 29 to positive. Let me do another one. Actually, just got finished listening to the Amp Hour podcast with Chris Gamble and Dave from the EEV blog, and they mentioned it's kind of weird. All of a sudden, Chris just asked Dave what he thought about robots. It's very random. And Dave was like, yeah, I like them. I don't have time for them. I don't see how he doesn't have time. This is all he does. He can do whatever the hell he wants on his blog. If he doesn't have time to build a robot, then he's not doing it right. Because he can incorporate that right into his current work. So I don't understand that comment. Time for some Red Bull. Alright. Okay. 27 to 29. I don't know what's going on here. I'll just go with it. Alright, 27 to 29. Probably an easier way to do this one, but let's go with it. This is some tedious shit here. It's going to be too long. One thing from doing this before that I learned is that you want to make sure you don't go across the top of stuff or block stuff in. Just on the off chance that I should fry one of these chips, I don't want to make it super hard to pop it out and pop a new one in. I mean, really, these, with this level of the stuff I'm working with here, it's not the cost of the stuff, it's the work. The time. Okay, now we're going 13 to 30. And I am going to be like figuring out a total cost on this project at some point. I was hoping to keep it really low. I've already made it a little more expensive than I planned because I'm using that serial LCD, which may not have been the best design choice, because serial LCD adds another $8, and if you look on eBay, you can actually buy an Arduino Mega clone for around $20, maybe 22. So might have been better off just using a regular parallel one. Okay, 11 to 26. Using a regular parallel LCD. And upgrading to a Mega might have made more sense. But I didn't. Okay, that was 11. I said 26, I believe, yep. Getting that measurement on that, 11. But really, with this simple little robot platform, you can use whatever microcontroller you want. And you don't have to use the, you don't need an LCD. The main reason I wanted the LCD is, for one, these blue backlight LCDs, they're just cool looking when they're running. So the cool factor is one thing. Then another thing is, now we're going 10 to 29. I'll start talking again in a minute. Let me pay attention to this one connection. 10 to 29. But anyway, another thing is that what was I saying? Oh, the LCD looks cool, but I really wanted to have a easy way to debug all of those ultrasonic sensors I'm going to have on this sucker. Okay, 9 to 28. I'm going to have so many of them, and I think it's going to take me a little while to get the code down, and I want to be able to tell at a glance what each one is doing. And I said 28, yep. About a key. So if I can just have it up, constantly updating the distances and whatnot, then I can tell if the code is running correctly based on what the inputs are. And I can also tell that the sensors are actually doing what they're supposed to be doing. And it's always good to have some way of producing output for debug, if nothing else. Wow, that's short. Okay, now that's just going to the rail there. Okay, so we're taking .24 going to the positive rail. That something doesn't sound right here. Well, I'll double check it before I start it up. 24 to the positive rail. Doesn't seem right. Something isn't right here, because I have, right now I think I have 3 pins going to the positive rail. 27 is coming here. One of them's a reset, one of them goes to VCC. I don't know what the other one is. I need to look that up right quick. Let's take a look. remote and ground. Okay, that is actually going to be, yeah, I was right. This is actually where the battery pack positive is going to go. So I need to pull that. This ground is good. They're going to share a common ground anyway. So this can go to ground if it'll stretch. Which it will. It'll stretch fine. Okay, so this is 1, 2, 3, 4, 25 to 28 are all motor connections, and 24 is going to be positive voltage, and then this is the ground here, and I can just tie the ground from the battery pack into the rail here. I'll be good. So I've only got a couple more of these to do. I need to double check them before I do them. Okay, now the 5 volt is going there, the ground is going there. Okay, that's good. And that's just going to be the feed. What I'm hooking up right now is just going to be the feed from the voltage regulator of the Arduino to the 5 volt power rail there on the breadboard. Okay, so I have ground. And 5 volt. And this is actually going a little faster than I thought it would. That's usually not the case for me. Things usually take way longer than they should for me. Which usually is a result of me not knowing what I'm doing. Okay. Alright, so we're all good there. Now, call this A over here. And I think I did did negative into 1, positive into 2. Okay, A is up top, A and 2. Okay, it's right here. And 1 is going to be right here. Okay. I don't like going over the top, but that's alright. We got, okay, standby. Let me see. 1, PWMA, and 2. Oh, wait. I've got something messed up here. Let's see. Oh. looking at the wrong side of the board. Idiot. Okay. Now that's VCC, and then it goes AO1, AO2, then it goes BO2, so then I'm going to have my negatives next to each other. And if my robot's going backwards, then I'll be able to be a simple matter of just reversing these reds and blacks here. Okay, so now go ahead and, man, I hate these connectors. I'm gonna have to redo these things. But for now, I'll go ahead and just tie this end to any old ground. Doesn't matter a bit. Okay. Then I'll tie this in. Okay, V-mote. Make sure I have the right orientation here. V-mote is one up from here. It's 24. I really want to open this battery case up and put some thicker wire in. Okay. We're a lot better off now than we were a little while ago compared to the spaghetti we had. I mean, you're going to have a lot of wires just because it's a robot, but this is a lot better. I'm going to take a break. I'll be right back. Okay, so I loaded up this motor test software that you might have seen me run in the previous video, and I'm going to go ahead and simplify this test a little bit because it's doing all this stuff here, and I don't really want it to do that much. So I'm going to delete all this. Let's see, I'm going to do go forward. I'll do go backward. And the delay is just how long you want it to do that for. In this case, it's going to be 2 seconds. It's going to go forward 2 seconds. It's going to go backward 2 seconds, and it's going to turn around and do it all over again. So I'm also going to make this, I'm just going to delete out the functions I'm not using just to make it shorter on the website. Let's delete all that. Got turn around in there. Okay. And I'll do a quick verify. Uh-oh. Oh shit. I guess I shouldn't have took out rotate left. Alright, let's see. Can I go back? Okay, I'll leave rotate left. I just have the functions I'm actually going to use in this run, and I'll save this as motor test simple. Let me verify it real quick. Okay. That's interesting. This actually compiled to like only 200 bytes.
It's only 200 bytes smaller than the other code. Okay, so I'm going to go back and we're going to upload this code. Alright, so now I'm just going to plug in my Arduino. And I'm going to upload that code I just wrote, or just modified. Okay, looks like it took it. So now a couple of quick things I'm going to do. Go ahead and install my batteries. And like I said, I'm going to be using 3 rechargeable AA's, which this should be giving me an output of I think 3.6 volts. We'll check it out real quick. See what we got on the old 1-ton low meter here. Let's see. Measuring this right. Looks like I got 3.8 volts. So each one of these must be, measure one by itself. Oh, okay. They're 1.28 volts. I thought they were going to come in at like 1.2, but they're a little bit hotter than I expected. But that's fine. That's within a tolerable range. So now I just need to hook up a 9 volt, and we'll be able to run a quick test of this thing in this room. Test this 9 volt real quick before I put it in. And I had a little 9 volt holder. Here we go. And this is going to be supplying power for everything but the motors. Okay, so I'm going to do the ground rail there, and this should be so got a voltage in. I have to kind of pick up the bot so it doesn't go nuts on me when I hook it up. Figure out somewhere to put this thing. Just sitting in there loose. And what we should see, put this camera down. Okay, and it's running, you can see it's running the program. It's going forward, and it's going backwards, and it turns around. Looks like it's spinning right though, so I'm going to have a little work to do. I've got something backwards. Maybe I'll just probably just change up the A and B motors, or I could change the code either way.
but it appears to be working good, so I'll be able to move on to the next step.